In the first video, I showed Cozy in action and promised to return to the installation steps. This is that video. We install Cozy from scratch and look at what actually happens during the install. Cozy's primary target is SBX, Docker's standalone sandbox runtime. It creates isolated Linux virtual machines where you work with AI agents, so the only prerequisite is the SBX CLI itself. The install steps are in Docker's docs. Link in the description. The whole quick start is 3 commands. First, clone the Cozy repo and cd into it. Second, create the sandbox. Let me unpack it piece by piece. --name demo names the sandbox. Shell is the agent, the standard sandbox image from Docker. --kit sbx kit layers Cozy on top. A kit is a small spec file that says what to run inside the sandbox after it is created. The last arguments are folders from my Mac that get mounted into the sandbox at the workspace. The first one is where you start. One thing to note, the kit installs Cozy from GitHub, the latest commit on the default branch, not from this local checkout. The clone is only needed for the kit file and the WezTerm config later. While SBX create runs, it looks completely silent. SBX swallows the install output, but the installer writes everything to a log file, so from a second terminal I can watch the progress. Here SBX exec-it opens an interactive shell in the sandbox and tail-f follows the log as it grows. While it installs, let's look at what it actually does. The kit itself is one small file. First, it sets the sandbox environment variables. This block mirrors the env of the Docker image. Then the network allowlist, the only domains the install may reach. Homebrew, GitHub, the apt mirrors, Claude AI, nothing else. And it runs 2 commands. The first clones Cozy into the sandbox. Shallow, the latest default branch. The second runs run-install.sh, its output redirected into the log we're tailing. It makes sure Homebrew is present. In the sandbox Linux passwordless sudo, it installs brew automatically. On a real host, it stops and shows the command. Then it hands off. There is a small step that picks a Nushell able to run the installer, pinning a known good version if brews is too new, but that's plumbing. The real work is in bootstrap.nu, the main installer itself written in Nushell. Here is the install plan, step by step. Every step bootstrap.nu runs to turn a bare sandbox into Cozy. First, brew installs the toolset. The full list is on screen. Then a minimal git config with an agent identity. The installer itself needs to commit. A real user's own ~/.gitconfig still wins over it. Next, the vendor Nushell modules fan out into ~/repos, straight from the committed vendor snapshot, so no extra patches. The autoload script are what load the modules on every shell start. The dir is wiped first, so a file removed upstream doesn't linger. Then the dotfiles are deployed and the Claude Code skills installed. My global Claude instructions, the tool catalog, are appended to ~/.claude/claude.md. Broot gets its default config. Topiary gets the three-seater new grammar, compiled locally so Nushell code can be formatted. Claude Code is installed and the Nushell MCP server registered, so the agent gets a persistent Nushell session out of the box. And the very last write is a small stamp, last on purpose. A failed install leaves no stamp, so nothing pretends to be complete. When the log says the install is done, the third command connects to the sandbox. Here new --login--execute starts a Nushell login shell inside the sandbox and runs one command, zelich attach -c Cozy, which attaches the zelich session, creating it on the first run. On my Mac, I actually connect through WezTerm instead. One command opens a window straight into the sandbox, with the quick select patterns and combines I showed in the first video. Here is that command. The config it loads, highlighted, is rendered in the Cozy. To check that everything landed, Cozy ships its own check, Cozy verify. Inside the sandbox goes through the environment and reports what works. On Windows, the CMDK doesn't exist and WinKey combinations are reserved by the operating system. So run cozy swap zelich super inside the sandbox to remap the zelich bindings to alt. Thanks for watching and stay tuned.